Hello there, this is Samurai Goblin. Welcome to my channel. This is part 2 of an ongoing ray tracing series. Last video we looked at how to write pixel data to an image file, specifically PPM file. It's very easy to understand, so go check it out if you haven't already watched it. Today we're going to be doing something equally simple, and that's just tidying up the code and making color class to store the red, green, blue components, and making a screen array to store the colors before we save them out, that kind of thing. So I'm just going to copy what we did last time, and let's open it up. Okay, so that's what we did last time. Let's just run that. And we'll go to the folder, because we're going to need to do that. And there we have it. That's what our code does. It creates a small image and fills it with random pixel colors. Right. We don't want this in the main function. We want to kind of start separating this all out. So let's create a function to do that. Void save screen, let's call it that. Okay, and let's just move the code into there, and we will call this function. We will pass in the width and the height. Const int width, const int height. And we will also pass in const car start, not chat, file path. And pass that in. Okay, so that does exactly. Oh, we need to not return anything. We're not doing any error checking. Just keep it nice and simple. Okay, so that should do exactly what we have already been doing. It's just in another function. I'm going to move that to a new file. I think I'll just call it screen. Yes, in source. There we go. Create that. Huh, why did it put it there? It's a bit weird, but it's in the right place. Okay. So I want to copy this function. Keep my main nice and clean. Okay, and need the prototype in here. Okay, that's nice and clean. We need to move that to here, and we need to include that in here. That theoretically should work. Yes, succeeded. Right, so we have this successfully in here. What do we need to do now? Let's just make a color class, and we'll just store it as floats. We got red, green, blue, and alpha. Yep, that'll do. And we want to create a screen. We want to create an array of colors that we can write to and save out. So let's include vector. This will give us some kind of array which we can use as a screen. So vector of colors. Oh. And we'll call that screen. Let's put it in here. pass it to our save screen function, so we will need to add that to here, and it should be a reference. We don't want to copy it, but we need to know what vector is, so we will have to put that in there, and we need to know what color is. Let me put the color in here. It's a bit dirty. We should put it in a separate file, but that will do for now. And we need to copy this to here. Okay, let's build that. And it failed because two commas. Okay, so that works. We are creating an array for our screen, but we're not giving it any dimensions yet. So width times height. So this vector is a linear contiguous area of memory of lots of colors, and if we pass in width times height in the constructor, it will give us enough memory for a screen's worth of colors. So our screen is set up nicely. It's not initialized though, but that's okay. We are passing in, I think I'll reorder these. Just for fun. Okay. That builds. Okay, so we create our screen and we save our screen. At the moment we're not doing anything with it. We're not actually saving the data from the screen. So here we're just saving out random component values, but we actually want to be looking into the array. So we need an index into the array based on these x and y. We need to convert that into a linear index. And the way we do that is simply, call it I, is x plus y times the width. Okay, so y times the number of pixels in a row plus the index into that row. That gives us our index for the color that we are wanting to write. Let's get a reference. We const col equals screen I. There we go. We've got this is mirroring the actual color at this location, at the ith location in the array. So we can just col dot whatever times 255, and that's R, G, and B. And there we have it. So this will be, these values in the color will range from 0 to 1. But we want to save it as a byte, so we need to multiply it by 255 to get it as a float in the range 0 to 255, and then we cast it to an unsigned integer, an unsigned byte, and write it to the stream. That's very clear. And now we need to actually render the screen. Let's make this a bit more compact. So we create the screen and we save the screen. We actually need to put some color data into it. Now this is where we will do all the calculations for the ray tracing to calculate the colors that we put into the file. But for today we're just going to fill it with simple colors. So we will pass in all this information to the render function. The screen to be written to, the width and height of the screen. We should really pack this into some kind of class, a screen class, but maybe we'll do that later. The render function needs these 3 parameters, and let's just copy this. So we iterate over every pixel in our screen. We've got a handle to the particular color. So let's just put col equals, and let's just say red for now. If we run that, we don't want this constant, that's the problem. We run that, we get a red screen. There we go. So that's what we're doing. We've split it up. Before we were just writing, creating random values and writing them at the same time. But now we've split into 2 separate processes. One is to just render the colors and store them in some kind of array. And then after that, we just write them out to the file. So let's just make it a little bit more interesting than red. Let's make colors based on the X and Y locations. So something I like to do with these kind of 2-dimensional screen coordinates is normalize them to be the range 0 to 1. So we have y that goes from 0 to h minus 1. So I will make a float fy, floating point value y, equals float y divided by height. Right? Now, can you see a problem with that? The problem with that is that y doesn't actually go to h. So y only goes to h minus 1. So if we divide by h, we're never actually going to reach 1. We're going to reach 9 point, whatever it is, depending on the resolution. So we should divide by h minus 1. I cast it to a float, otherwise we would get a bug where we have an int divided by an int, and it will just give us a 0 or a 1 or something, and that would put that into a float. So I need to cast it to a float. I can actually not do that if I make this a float. There you go. H is an int minus 1.f is a float. It will turn that into a float, and that's an int divided by a float will return a float, and so everything will be fine. And I can do it here as well. Okay. Some people might do it like this, right? But since y doesn't change for every x, there's no point in doing that. You can optimize it out and put it in the loop above. Of course, the compiler will probably be clever enough to deal with that, so you don't need to go down to that level, but I'm old school. So, something else I like to do, and I'm not sure if I should do this now. This I is calculated with a plus and a multiply. But really, if you think about what's happening, is we are iterating through the array completely linearly. We don't move around all over the place. So what I often do is, in the outer loop, I create I and initialize it to 0, and on the inner loop, I just increment I, and then I don't need to do this calculation for every pixel. Every pixel is just doing this one operation. Of course, again, the compiler will probably, deal with that, and also at such a low level, you don't need to be doing this kind of optimizations. I learned this stuff like decades ago when it did matter, but it doesn't matter anymore. So let's just take that out. Also, when it comes time to do some multi-threading, we can't rely on the order, so we do need to do it this way. I just thought I'd show you that, just as a tangent. Okay, and let's just put fx and fy in there and run it and see what happens. There you go. That's great. So now we have red component based on fx, which goes from 0 to 1, and the green component based on fy, which goes from 0 to 1. And so the color here is 110 because we put a 0 in for the z component. Let's put a 1 in for the z component, make it a bit prettier. And there we go. Looks like that. So we have successfully created our color structure. We're not really doing much with it, apart from making a screen which we pass in all over the place. We render, we create we work out or calculate the color values for each pixel and store them in the screen array, and then we save the screen and write them out to binary byte data. Okay, that's it. That's what we've created. It's a little extra step from last video, but it's a good step. Okay, that's it. So I think in the next video I'll be talking about vectors. So stay tuned. Please like, subscribe and share and all that kind of stuff. And thank you very much. Bye.